Good day, everyone. I am Miss Jiezyl Jamaica M. Aquino, Teacher 2 of Don Eulogio de Guzman Memorial National High School, SDO La Union, and today I will be presenting my action research entitled Effectiveness of Contextualized Guided Interactive Notebook or CGIN in Enhancing the Learning Competency on Integrals in Basic Calculus of STEM 11 Learners. Since health had been a relevant issue all over the world, the education sectors strive to overcome the challenges of COVID-19. Most educational institutions around the world have temporarily closed, bringing about an unforeseen public health crisis so that the spreading virus is contained and infection is lessened according to TRIA 2020. As an immediate response to the crisis, the Department of Education instituted DepEd Order No. 12 Series of 2020 to establish a new learning delivery modality in all levels, embodied the Learning Continuity Plan or the LCP for the school year 2020 to 2021. During the course of the teaching process, the researcher observed that the senior high school students had difficulty in the subject of basic calculus during the second semester of the school year 2021 to 2022. This led the researcher to produce a contextualized guided interactive notebook or CGIN for basic calculus in the fourth quarter. This study aimed to determine the effectiveness of contextualized guided interactive notebook or CGIN in enhancing the learning competency on integrals in basic calculus of STEM 11 learners of Don Eulogio de Guzman Memorial National High School during the school year 2021 to 2022. Specifically, this study aimed to answer the following questions. Number 1. What is the level of competency of STEM 11 learners on integrals in basic calculus before and after the intervention? Number 2. Is there a significant difference in the pre-test and post-test performance of the STEM 11 learners on integrals in basic calculus before and after the intervention? And number 3. How does the contextualized guided interactive notebook or CGIN intervention improve the learning competency as perceived by the experimental group? And CGIN, or the Contextualized Guided Interactive Notebook, is contextualized, guided, and interactive in design as a notebook, and it is a good avenue to assess the extent of understanding of the learning competency of the learners by allowing them to write their answers in the notebook using the Ilocano, Filipino, and English language. There are 3 primary phases in this intervention. The first one, creation and design of the Contextualized Guided Interactive Notebook, or CGIN. Number 2, quality assurance of the CGIN content and design through a validity test. And number 3, the pre-test and post-test administration. The research design of this study is a quasi-experimental 2-group design and a descriptive phenomenological design. 2 participant groups in the study, namely STEM 11 Alcaraz and STEM 11 Alexandrians, each with 32 students. A total of 64 participants for the study were gathered by the researcher. The researcher utilized the total enumeration sampling technique. The researcher adopted the 15-item question as the researcher instrument, pre-test and post-test from the EARS learning module in basic calculus for the fourth quarter. Module 1, Antiderivative of Function. Using the SPSS statistical tool, the data are analyzed. To answer the first question, it utilized the average mean and the mean percentage score. Moreover, in answering the second question to determine the significant difference between the level of competence of STEM 11 learners on integrals in basic calculus during the pre-test and post-test, it utilized a z-test. In answering the third question, the researcher utilized a thematic analysis approach. For the results and discussion, Table 1 reveals that STEM 11 Alcaraz, which is our control group, obtained a pre-test mean score of 6.84, having a mean percentage score of 45.60%, while STEM 11 Alexandrians, which is our experimental group, obtained 5.63 in their pre-test mean score, having a mean percentage score of 37.53. This means that they have limited knowledge about the said competency. Moreover, the table also reveals that the STEM 11 Alcaraz, which is our control group, had a post-test mean score of 11.97, having a mean percentage score of 79.80%, while STEM 11 Alexandrians, which is our experimental group, had a post-test mean score of 14.38, having a mean percentage score of 95.87% in their post-test mean score, which implies that the experimental group had shown a high level of competence using CGIN in comparison with its pre-test result. Table 2 reveals that for the control group pre-test and post-test without CGIN, the computed z-value is 19.65, which is greater than the z-critical value of 2.04 for a two-tailed test and a level of significance alpha of 0.05. This indicates a significant difference between the control group's pre-test and post-test results. Furthermore, for the experimental group pre-test and post-test with CGIN, the computed z-value is 32.94, which is greater than the z-critical value of 2.04 for the two-tailed test and a level of significance alpha of 0.05. In other words, there is significant difference between the experimental group's pre-test and post-test results. Additionally, for the post-test of the control group and experimental group, the computed z-value is 13.75, which is greater than the z-critical value of 1.96 for the two-tailed test and the level of significance alpha of 0.05. This implies that there is a significant difference between the post-test scores of the STEM 11 Alcaraz, which is our control group, and the STEM 11 Alexandrins, which is our experimental group. Thus, using CGIN is effective as an intervention to enhance the mastery of the level of performance of the learners, specifically on integrals in basic calculus compared to the use of the printed modules alone. Table 3 reveals the major themes and sub-themes that appeared from the data gathered by the researcher as well as the participant code in each corresponding sub-theme. Summarizing the narratives and responses from the participants, one major theme has been identified, and that is the improvement of students' learning competency through the Contextualized Guided Interactive Notebook or CGIN. The major theme is then presented with its corresponding sub-themes, namely, first is the academic performance, second is the skills and knowledge development, and third is improving real-life relations. For the academic performance, with that, it is seen that CGIN has been used as a guide to improve the participants' academic performance altogether. For the real-life relations, with the CGIN, it is found that the participants have not only developed but also acquired a new set of skills and knowledge while using it. As stated by participant 11, the interactive notebook is essential in teaching and helping students acquire new skills and knowledge as they would be able to use it in the real world. For the skills and knowledge development, with the creation of CGIN, findings suggest that the incorporation of real-life relations to mathematical problems efficiently help and improve students to understand and analyze the set of problems handed to them, since they could relate to and associate themselves with a given example. For the conclusion, based on the findings of the analysis, the researcher concluded that the CGIN produced was effective in enhancing the learning competence on illustrating an antiderivative of a function and computing the general antiderivative of polynomial, radical, exponential, and trigonometric functions in basic calculus. The CGIN formulated is an excellent teaching tool and intervention material as evidenced by a comparably high competence post-test mean score compared to the pre-test mean score of the experimental group. CGIN as an intervention showed promising benefits in enhancing the learning competency on integrals in basic calculus as attested by the experimental group who were exposed to the CGIN as an intervention and with the following benefit as first, academic performance, second, skills and knowledge development, and third, improving real-life relations. Therefore, to improve the level of competence in learning concepts in basic calculus, teachers must use or create similar materials if the CGIN is limited. The teacher can develop and improve materials and modules that may be of interest to students. Furthermore, teachers could create contextualized modern material that students can relate to. Further study in the development of another instrument or collection of CGIN is encouraged to be reinforced in the teaching of other fields of mathematics and disciplines at various grade levels and to be used in other subjects. The following are the references used in the study.